Hello everybody, and we have advanced physics for all top exams, and we have today vectors 4. So we have already seen the basic concepts of vectors. We have seen how we add vectors into a resultant. We do it with the triangular law of adding, or we use the parallelogram law of forces or vectors. Now we also can break a resultant into its parts, reverse process, or it's called actually resolution of vectors. It is a good idea to break one vector into what is called rectangular components. What does this mean? Suppose you have a two-dimensional vector and we want to have two one-dimensional vectors. One on the x-axis, one on the x-axis and the other on the y-axis. One on the x-axis and the other on the y-axis, which means if you add the one on the x-axis and the one on the y-axis, we should get back what we are breaking. These two one-dimensional vectors sum up and give the original vector. You understand? These two one-dimensional vectors again sum up and give the original vector. So, for example, if you have a vector of 10 units and at 60 degrees to the x-axis, then the component of the x-axis is actually A cos theta and the component of the y-axis is A sin theta. A sin theta. Let us check whether this is true. We have seen that r square is equal to a square plus b square plus 2ab cos theta last time. Which means here it is a sin square theta plus b cos square theta plus 2ab cos 90. 90 because they are rectangular components. So it will be 10 into sin square theta plus cos square theta plus 0 as cos 90 is 0, which is equal to 10, which is we got back 10. See? So like this we can derive in a more formal way. So it's a fact we can break a vector into two components along x-axis and along y-axis if we have, say, 10 forces acting on a body. I'm now going to tell you why it is so powerful, this concept. If you have 10 forces acting on a body at different angles, and if you break each one into components in x-axis and y-axis, then finally we will have what? 10 vectors along x-axis, 10 vectors along y-axis. Now each can be added very simply, isn't it? Because it is one dimensional. As it is one dimensional, we can add it easily. And finally we'll have, after adding, one total value of the vector along x-axis and one total value along y-axis. So resultant can be got by r square is equal to a square plus b square. So one value of the vector along x-axis, let's say a, and the one along y-axis could be b. So what have we done here? We have actually made the process of adding vectors very simple by breaking each vector into rectangular components in x-axis and y-axis, then adding x-axis vectors, adding y-axis vectors, then finally adding all the two x-axis and y-axis vectors. So result can be got r square is equal to a square plus b square, where a is the total value of the vectors in the x-axis, b is the total value of the b on the y-axis. So r is the root of a square plus b square. The final angle would be tan b by a, where b is equal to y component and a is equal to x component. So these are the basic concepts and also formula. So when you have a vector and we break it down into two components, it is, suppose you have a vector called c, then it is c cos theta in the x-axis, c sin theta in the y-axis. Tan alpha is equal to y by a. Tan alpha is equal to y by a. What is alpha? The resultant. Okay. So that is the breaking tool. So what are we doing here? We are breaking a vector, two-dimensional vector into two one-dimensional vectors, that also on the x-axis and y-axis. Very easy to add. We'll see it very, very clearly, especially in the chapter on forces. Now we also have product of vectors. It has a very special meaning. I'm only mentioning it here. A dot b is equal to ab cos theta. A cross b, there are two products. It is not at all the product which we know as arithmetic. It is vector product of vectors. So what is the meaning of this? We'll see these concepts by linking it to physics in later chapters. Because this is physics lectures, you will understand it completely. This is actually A dot B is used in the work chapter and A cross B is used in two other chapters later. So that actually completes vectors for us. Let's revise. We started with what is a vector. It is inherently, it has magnitude and direction. This is a summary I'm giving. Then we gave the basic definitions: alike vectors, unlike vectors, unit vectors. Then we decided how to add. So we had two laws: the triangular law of vectors and the parallelogram law of vectors, where we added. We had a formula: r square is equal to a square plus b square plus 2ab cos theta, and also for the angle. And we also, today we understood, in this video we understood the resolution of vectors. We can break a two-dimensional vector into two one-dimensional vectors, that also rectangularly, which means along the x-axis, along the y-axis, add all the x-axis vectors, add all the y-axis vectors. We'll get one value for the x-axis vectors, one value for the y-axis vectors. Those two again can be added by r square is equal to a square plus b square, because ab cos theta will be 0. So that is what we have, the basic concepts. We have completed the basic concepts of vectors. You will understand vectors more powerfully, more completely, when you apply it into problems, and we'll do it in the next chapter and the coming chapters. Thank you so much.